All right, in this lesson, we're going to begin chapter 2, which is all about functions. All right, we're going to start this section with linear equations in two variables. All right, so a lot of the stuff you guys have seen before, perhaps the most prevalent kind of equation of a line that you guys have seen is the slope-intercept form of a line, which is y equals mx plus b. All right. In general, this is how you're going to write your answers unless otherwise specified. But if you're given an equation in slope-intercept form, it's in the name, right? You get a slope and you get a y-intercept. All right, so some of the simplest kinds of equations to graph. Another fairly simple equation is a point-slope form of a line. All right, and again, just like slope-intercept, it's in the name, right? You have a slope and you have a point. All right, this is something that is going to be useful to us in the later half of this lesson when we write the equation of a line, right? Because depending on the information that we get, this is typically the quickest route to go about writing the equation in slope-intercept form. Like, let's say in a problem we give you a slope and we give you a point, then you can easily convert it to slope-intercept form by first plugging it into this formula. All right. Standard form is another common equation of a line. This gives us not so much information. We typically use it to find the x and y intercepts, just because to find the x intercepts, you can just ignore the y, and to find the y intercepts, you can ignore the x. But typically what we do, like let's say I want you guys to graph a line in standard form, what you would do is you can convert it to slope-intercept form. All right, one thing to note about standard form is that there are no fractions or decimals, so a, b, and c are all integers. All right, and more specifically, whatever's in front of the x has to be a positive integer. All right, some more discussion about slopes and intercepts and lines. All right, so we discussed the concept of a slope. A slope is just the measure of how a line is changing from one point to another. All right, so from left to right, you're seeing how is the line changing, right? So maybe you have a slope that looks something like that, or I'm sorry, you have a line that looks something like that, and you see that it's going up from left to right, right? And so this would be a positive slope, right? Another positive slope would maybe be something like that, right? Because it's still going up from left to right, but you can clearly see that the blue line that I drew on the right is going up faster than the one on the left is, right? So you would say that the one on the right has a bigger slope than the other one. All right. Similarly, we can go in the negative direction and it would look something like that. It's going down from left to right. This has a negative slope, so it's changing by going down. But just like before, you can kind of measure the steepness of how fast it's going up or down, right? So let's say I drew another red line that's still going down from left to right, but it is less steep than the one that I drew on the left, all right? So this has a less negative slope, right? It has a smaller slope, all right? On a graph, you can find the slope by doing the rise over the run, right? So you're just counting how many units it's going up or down over however many units it's going left or right, all right? And then what's going to be useful to us later on is this formula right here, which is y2 minus y1 over x2 minus x1. So stuff that maybe a lot of us remember from Algebra 1. This is useful when we're given 2 points and we're asked to find the slope or write the equation of a line between 2 points, right? You can easily find the slope just by plugging it into this formula. All right. The x-intercept discusses where the line, like let's say any given line, crosses the x-axis. So let's just say this is my xy plane right here, and then I have a line that looks maybe something like this. All right, this point right here would be considered the x-intercept because that is where it's crossing the x-axis, and it's always going to have an ordered pair, a number, right? So your x value, comma, 0. To find it mathematically, you would plug in 0 for y, just because by looking at this little graph that I drew, the y value is 0, right? And that's always going to be the case for any intercept, right? It's either x is 0 or y is 0. All right, similarly, the y-intercept, let me draw another little graph over here, is going to be where the graph intersects the y-axis. So let's say I drew that exact same line, and then you can see that it's crossing the y-axis at this point right here. All right, so again, x comma y would be 0 comma a number, right? Because this is where x is 0, and there's a number for y, right? And to find it mathematically, you would plug in 0 for x. All right, with vertical and horizontal lines, right, these are kind of special because the slope, you're going to describe it a little bit differently than how we did in the previous slide. All right, so a vertical line goes straight up and down. All right, so something like that would be a vertical line. And this has no slope. It's undefined, right? So what we're saying with a vertical line is that from left to right, it is not changing at all. It's just staying in the same spot, going straight up and down. So really, there's no way to define a slope for this. This slope is undefined. And the equation of a vertical line is always going to be x equals a number, right? Let's just say that this is my xy plane. You can see clearly that it's crossing the x-axis at a number, and it's never going to touch the y, right? So that's why it's only x equals a number. Now, a horizontal line has a slope of 0, all right? So if I were to draw this from left to right, there is a way to define it from left to right. It's just not going up or down, right? So that's why we say it has a slope of 0, right? It's not changing. It's not, it's staying all in the same, it's at the same level the entire time. All right, so this has a slope of 0. Something to keep in mind is that a slope of 0 and no slope are two different things, right? They mean completely different things. No slope, it doesn't have a slope. A slope of 0, it has a slope, it's just 0, right? And then again, it would be y equals a number, right? Let's just say this was an xy graph right here. So let's just say it looks something like that. You can clearly see that it's crossing the y-axis at a point right here, all right? And it's never touching the x. One way that I like to remember vertical and horizontal lines, maybe some of you remember it from Algebra 1. I showed you guys in class, hoi vux, all right? It's like, if you guys remember SOHCAHTOA, it's like a little, it doesn't really mean anything in everyday language, but it's just a little thing to remember which one is horizontal and which one's vertical, right? So this H means it's horizontal. And then the hoi part of it means that this y, it's going to be a y equals equation. And then this O in the middle, that means your slope is 0. All right? And then the vux part of it, this V, if the H was horizontal, the V should be vertical, right? And then this X represents X equals a number. And then this U in the middle means your slope is undefined. All right? Mathematically, let's say if you're looking at the previous slide where I gave you 2 points and you find the slope and you do the whole y2 minus y1 over x2 minus x1, and then you get, for example, let's say you get a 0 on top. One way that I like to remember this is a 0 on top is okay, right? Okay, right? This is good. It just has a slope of 0, so it would be horizontal. But let's say I plug into this equation and I get 0 on the bottom. I like to say no, right? That is not okay, right? This is undefined. 0 on the bottom is not okay, right? If you try to plug into your calculator something divided by 0, you'll get no solution, right? So that's another way that I like to remember that. Now let's actually graph, right? I'm going to use a couple different colors because I'm going to graph all of them on the same line. I'm going to graph all of them on the same, this graph right here, all right? This first line is in slope-intercept form, right? Remember, slope-intercept form is y equals mx plus b. M is always going to be the number that's in front of the x value. So in this case, m is 2/3. And b is always going to be the number by itself, right? So in this case, b is 1. All right, and what this represents, m is going to be your slope, b is going to be your y-intercept. All right, when I taught Algebra 1, I taught them B stands for begin, right? You're always going to start by plotting your point there, and this M is going to tell you where to move from that point. All right, so let's start with our y-intercept of 1. If B is our y-intercept, I'm going to graph 1 on the y-axis, right? So the 1 unit above the origin is going to be this point right here, right? So if this is our center, hang on, let me point it out, right? If this is our center right here, right? 1 unit up is going to be right here, right? And then a slope of 2 over 3. Remember, your slope represents the rise over the run. All right, the rise represents how much you're going up or down, and the run represents how much you're going left or right. Since these are both positive, the 2 on top means you're going to go up 2 units, so 1, 2. And the 3 on the bottom means you're going to go to the right 3 units, right, in the positive direction. 1, 2, 3. And then I have 2 points right like that. And then I just need a graph and connect these 2 points. All you need are 2 points to graph a line, right? We already know what the shape is going to be, so we don't really need to get more detailed than that, all right? Good. All right, this next one is also a line in slope-intercept form, right? So this is y equals mx plus b. M in this case is -4. B in this case is 1. All right, so again, B begin at 1, right? The same point right here, all right? And then m equals -4, this means you're going to go down 4, but to the right 1, right? If that's confusing, anything over 1 is itself, right? So if you want to think of it like a rise over a run, just throw that number over 1, right? It's always going to work out fine, right? And if the top number is -4, that means you're going to go down 4 units, right? So from this 1, I'm going to go 1, 2, 3, 4 down. And then the positive 1 on the bottom means I'm going to go to the right 1, right? So 1 unit over here. And then I have 2 points, right? The y-intercept and that point that we just found. All we have to do from here is connect the 2 points. And so it looks something like that. All right. Excellent, right? So now this next one, right, is not an equation in slope-intercept form, right? This is actually in standard form, right? Standard form was ax plus by equals c. This doesn't really get us much information the way that it's written right now. You could use it to find the x and y intercepts, but I'm going to do what's most familiar, hopefully, to everyone, and I'm going to convert this to slope-intercept form. All right, so I'm going to take 3x plus 4y and take this and isolate the y. I'm trying to get the y by itself. So if I want y by itself, I'm going to get rid of everything around it on this side of the equal sign. So I'll subtract 3x on both sides. And so I end up with a 4y equals -3x plus 12. And then lastly, I want to divide by 4 everywhere. Right, divide all of these by 4. And so I end up with the y equals -3 over 4x plus 12 divided by 4 is 3. All right. And now this looks like something that's in our slope-intercept equation, right? This looks like an mx plus b, right? Y equals mx plus b. And so in this case, m, what's in front of our x, is -3/4, and b, what's by itself, is going to be 3. So again, b, begin at 3, right? So I'm going to pick a point right here, 3 units above the origin, and that is our y-intercept. And this slope of -3 over 4 is our rise over the run. And if our rise is going up or down and it's negative, we're going to go down 3 units. So I'm going to go 1, 2, 3. And then the run of +4 means we're going to go to the right 4. 1, 2, 3, 4. All right. And then those are our 2 points. I'm going to go ahead and connect these 2 points. Mine's a little crooked, but it's not that serious, right? As long as you don't make it look like an obvious curve, right? It's really not that big of a deal, right? So that's fine the way it is. All right. Now, this next one, right? Hopefully we can recognize that this looks different from the ones that we just did, just because there's something missing from here that the other ones had and this one didn't, right? So if it's a 3y equals 15, I only see the letter y. I don't see an x here, right? So if we remember, right, if it's just a y equals equation, this is going to be a horizontal line, right? Remember our hoy vux, right? This is going to be this part of it, right? A hoy, right? So if it's a y, then it's going to be a horizontal line, right? So I can imagine that it's going to look something like that, all right? Straight left to right. So to get the y by itself, I'm going to go ahead and divide both of these by 3. And so y equals 5 is the equation of this line. So then all I have to do here, it doesn't look like an mx plus b equation. It's just going to be at a y value of 5. And because I already know that it's horizontal, I'm just going to draw that straight line going across. Right? You can do this without remembering that Hoy-Vux thing, right? As long as you know that it's going to cross the y-axis at 5, right? If y equals 5, it's going to include every single point on this xy plane that has a y value of 5, right? So the only values on this xy plane are the ones that I'm highlighting right here, right? That have the y value of 5, right? Nothing else on this line is going to have a y value of 5, right? So it's going to look like a straight horizontal line, all right? And I can do something similar with the last one, right? So this one's a 2x equals 15, all right? Now, the special thing about this is that it has an x, it doesn't have a y, right? So if you think of Hoy-Vux, right, this is going to be the Vux part of it, right? So it's going to be an x equals equation, and it's going to be vertical, right? So I'm going to divide both sides by 2, and so I get x equals 15 over 2, right? This is the equation of our line. If you're not sure where to graph it, right, use long division, or do whatever you need to do to know where to graph it, right? So you can do long division, convert it to a decimal, a mixed number, that's fine, whatever you need to do, right? But if we do that, right, 2 goes into 15 7 times, and then you get a remainder of 1. So it's 7 plus a little more, or if you want to convert it to a mixed number, right, this is 7 and 1/2. Or what you can also do is convert it to a decimal as 7.5, right? All of these mean the exact same thing. So I'm just going to go ahead and find on my graph where x is 7. So 1, 2, 3, 4. All right, over here, this is where 7 is, plus a little more, so it's going to be somewhere right here. And then I'm going to draw that vertical line going straight up and down. All right, so that's the equation of our line. All right. And that's pretty much most of the cases that you're going to see when you're graphing a line, right? You'll either get it in slope-intercept form, or you're going to get it in a different form, and you'll have to convert it to slope-intercept form, or you'll get horizontal and vertical lines. All right, some other types of problems that you might see are ones where we just ask for specific information, right? And in this page, the only thing that we're asking for is the slope, all right? Some of them are going to be super easy, right? If you look at this first one, this is already in slope-intercept form, right? This is already a y equals mx plus b equation, right? And so m, your slope, is going to be whatever's in front of your x. So I don't have to do any math here, right? M, we already know, is going to equal 3, right? M always represents your slope, all right? So not much that we have to do there, all right? Some other problems you might have to think a little bit more, right? So 2y plus 1 equals 7, right? This one doesn't have an x. If it doesn't have an x, remember, Hoy-Vux, this is a horizontal line. And horizontal lines have a slope of 0. So this is going to be m equals 0. I don't have to actually solve this equation. If you did, you can subtract 1 on both sides, and you get 2y equals 6, divide both sides by 2, and you get y equals 3, but that still doesn't really give us much information that we didn't already have about the slope, right? So in this case, m would equal 0, right? Because it's horizontal, all right? Now, when you're given 2 points, what we can do is, one alternative is you can put it on a graph and actually count the rise over the run, all right? But that seems a little complicated sometimes, right? It's easy to graph, but might be a little bit time consuming, and you could make a mistake somewhere in there. So what we can do instead is we can use our slope formula of y2 minus y1 over x2 minus x1. So I'm going to label these x1, y1, x2, y2. And so I'm just going to plug this into my slope formula. This is going to be y2 minus y1, so 7 minus 3, over x2 minus x1, so 4 minus 4. And 7 minus 3 is 4, 4 minus 4 is 0. Remember, 0 on the bottom, no, right? We can't have this, right? This is undefined. So this would have a undefined slope. All right, another thing that you can say that it has, you can say that it has no slope. All right, no slope and undefined slope are the same thing. What you cannot say is that it has a slope of 0. So you can't say that, right? It does not have a slope of 0. A slope of 0 and no slope are two different things. All right, so hopefully that part's clear. All right, let's try this one now. So here I have 2 points. I can do the exact same thing as I did in the previous one, and I can label these x1, y1, x2, y2. So this is going to be m equals y2 minus y1, so 5 minus 2, over x2 minus x1, so 4 minus negative 3. And this is going to get you 3 over 7. All right. So your slope here is 3 over 7. All right. Now for this one, right, this is the equation of a line in standard form. Now in standard form, we don't really have much information given to us right away. So what we can do is we can convert it to slope-intercept form, so that way we can just look at the equation and be able to tell what the slope is. All right, so what I'm going to do is I'm going to try to get the y by itself. All right, so let's subtract 2x on both sides, and then we end up with a 3y equals negative 2x plus 5, and then I want to divide both sides by 3. And so we end up with a y equals negative 2/3 x plus 5/3. And now this is in slope-intercept form. Now in slope-intercept form, I only want the number that's in front of the x, so in this case, m would equal negative 2/3. All right. Lastly on this page, we have 2 points, which again, 2 points, I can just use the slope formula, so x1, y1, x2, y2, and then plug this in. So m is going to equal y2 minus y1, so 3 minus 3, over x2 minus x1, so 4 minus 5, equals 3 minus 3 is 0, 4 minus 5 is negative 1. And remember, 0 on top, this is okay, right? This is okay, which is equal 0. So m is 0. All right, now so you can do these types of problems, right? Sometimes we'll ask for other information, like maybe we'll ask for the y-intercept, the x-intercept, all right? And we'll deal with those once we get more problems like that, like maybe during a test or a quiz review. But this is what we have so far in our notes. All right, the second part of this lesson is going to be writing the equation of a line. So in these types of problems, you're given certain information about a line, and your task is to write the equation of it. Now, unless otherwise specified, you should be writing these answers in slope-intercept form. So you should always write them in y equals mx plus b unless we tell you otherwise. Now, the easiest case is this first part, right? This very first little bullet. If you're given the slope and you're given the b, you're going to plug directly into the slope-intercept form of a line, which is y equals mx plus b. All right, there's not much more that goes on there besides replacing the m and the b with the numbers. All right, what might require a little bit more work is if you're given the slope and a point. Now, in this case, you don't know what the y-intercept is, but you know what the slope is. What I like to do is this first option. I like to plug it into the point slope form of a line. And remember, the point slope form of a line is y minus y1 equals m times x minus x1. Right, so like I said in the beginning of this, in the beginning of this lesson, right, this is where the point slope form of a line is going to be useful to us, right? Because we're going to first have our equation look like this, and then we're going to write it in slope-intercept form, so it's going to look like a y equals mx plus b. The second thing that we can do is we can plug it into the slope-intercept form of a line, and then we can solve for b, and then you're going to plug b and the m that you were given into y equals mx plus b. All right, I definitely prefer the first option, right? And you're going to see what that looks like once we do some problems. The last potential scenario is if you're given 2 points, x1, y1, and x2, y2, you're going to use the slope formula, right? Remember, the slope formula is m equals y2 minus y1 over x2 minus x1. And I'm going to use that to find the slope, and then I'm going to use one of these two options to figure out the rest of the problem. All right, so here all we have is write the equation of a line, and it's going to look like a slope of 2, and it passes through this point. All right, so we're given a slope and we're given a point, it makes sense to plug it into point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. All right, so if m is 2 and our x1, y1 is going to be a -5 and a 4, I'm going to plug this directly into this equation. So it's going to be y minus y1, which is y minus 4, equals m, which is 2, times x minus x1, so x minus -5. All right, and then we simplify this as much as we can, and we try to get the y by itself. So what we can do, y minus 4 equals 2 times x minus -5 is x plus 5. And then I can distribute this 2. So I get y minus 4 equals 2x plus 10. And then we can add 4 to both sides. So we get y equals 2x plus 14. All right. And now let's try the same thing with the next one. Right, so this one's going to have a slope of -1/3, and it passes through this point. Now this point, again, I can write as x1, y1. We have an m and we have an x1, y1, so I can plug this into point slope form, which is y minus y1. So y minus -4 equals -1/3 times x minus x1, which is x minus 3. All right, we can distribute -1/3 and then turn y minus -4 into y plus 4. All right, equals -1/3 x. All right, -1/3 times -3 is going to get you a +1. Right, if you don't believe me, you can write -3/1 and do it off to the side, right? -1/3 times -3/1 is going to get you 3/3, which is 1, right? And then from here, I want to subtract 4 on both sides to get the y by itself. So we get y equals -1/3 x minus 3. And that's the equation of our line. All right. Now I'm going to do the same thing with this one. Although, actually, sorry, I take that back. We're going to do something different with this one, and I'm going to first find the slope given x1, y1, and x2, y2, right? If you're given 2 points, you don't have a slope, but you can find the slope. So I'm going to find the slope, plug it into this formula. This is going to be m equals y2 minus y1, so 5 minus 1, over x2 minus x1, so 2 minus 1. So it's going to be 4 over 1, which is 4. So my slope is 4. All right, that helps us a little bit. Now I just need to plug this into point slope form and then get the equation of my line. So I'm going to use, if you're given 2 points, you can use either point. I'm going to use this first one. You could do the second one, it doesn't matter, right? You'll get the same answer, but I'll just plug it into the first one. So it's going to be y minus 1 equals 4 times x minus x1, so x minus 1. All right, and now I can distribute that 4, and I get y minus 1 equals 4x minus 4. Add 1 on both sides, and I get y equals 4x minus 3 as the equation of our line. All right. Now we can do the exact same thing with this one. This is one where we can just find the slope again like normal. So I'm going to go ahead and plug this into our slope formula, m equals, and I'll label this accordingly, x1, y1, x2, y2, right? So this is going to be y2 minus y1, 7 minus 1 over x2 minus x1, which is going to be a 9 minus -3, all right? And 7 minus 1 is going to get you 6. 9 minus -3 is going to get you a 9 plus 3, which is 12. And then simplify this as much as you can, right? Divide the top and the bottom by 6, and this is going to get you 1/2. So my slope is 1/2, right? And this helps us because I can now plug this into point slope form. Again, I'm just going to use that first point. It doesn't really matter which one you use. I'm just going to do the first point, and we're going to make this into y minus y1. So y minus 1 equals 1/2 x minus x1. So x minus -3, which is going to become x plus 3. All right. And then I can get my y by itself, distribute 1/2. I get y minus 1 equals -1/2 x plus 3/2. And then I can add 1 to both sides. And then I end up with y equals 1/2 x plus 3 over 2 plus 1. All right, and to add a fraction and a whole number, we need a common denominator. So I'm going to write this 1 over 1, and then times 2, and I get 1 times 2, which is 2. And I do 3 plus 2, which is 5. So this becomes y equals 1/2 x plus 5 over 2. And then this is the equation of our line. Right? The only tricky thing about these problems is adding fractions and whole numbers, right? But once you practice it, it shouldn't be that bad, right? And this should be a skill that we're fairly comfortable with at this point in the course. All right, the last topic in this lesson is going to be parallel and perpendicular lines. So these kinds of problems are going to be worded the exact same way as the previous slide. It'll just say find the equation of a line parallel to something or perpendicular to something. If it's parallel, it's going to have the exact same slope as whatever line you're comparing it to. If it's a perpendicular line, it's going to have an opposite reciprocal slope, right? So just change the sign and flip the fraction. And then I'll show you what that's going to look like with these kinds of problems. All right, so I want to write the equation of a line parallel to 4x minus 2y equals 3 passing through this point. Well, first, I want to know exactly what the slope of this line is, right? And so to find the slope of this line, I need to convert it into slope-intercept form, right? So I'm going to subtract 4x on both sides, and then we end up with a negative 2y equals a negative 4x plus 3. And then I want to divide both sides by negative 2. And then I end up with a y equals, these negatives cancel out, and 4 divided by 2 is 2. 2x minus 3 over 2. I don't care about this negative 3 over 2. We only care about the slope here, right? Because we're going to write a new equation of a line that passes through this point, right? So the y-intercept is going to be different, but what we know for sure about parallel lines is that they have the same slopes. So I'm going to plug m equals 2 and x1, y1 as 2, 1 into point slope form, and I'm going to write the equation of this line. So this is going to be y minus 1 equals m, so 2 times x minus x1, so x minus 2. And then just distribute and convert this into slope-intercept form. So this is going to be y minus 1 equals 2x minus 4. And then I can add 1 to both sides, and this is going to be y equals 2x minus 3. All right. So now we can do something similar with the next one. Just the only thing is the next one is going to be a little bit simpler, right? Just because it's already in slope-intercept form, and I know that it's parallel, so I can just take the slope and plug it into point slope form, right? So my parallel slope is going to be m equals negative 3, and then I'm going to plug it into point slope form using x1, y1 as 2, 5. So it's going to be y minus y1, so y minus 5, equals m times x minus x1, so negative 3. Whoa, that looks bad. Negative 3 times x minus x1, so x minus 2. And then I can distribute negative 3. This is going to be a y minus 5 equals negative 3x plus 6. And then to get the y by itself, I'm going to add 5 on both sides. So it's going to be a y equals negative 3x plus 11. All right. And that's how we handle parallel lines. Now to handle perpendicular lines, we're still going to find the slope, right? And I'll show you what that's going to look like. So perpendicular to this line, I first want to know what the slope is. So I'm going to do exactly what I did before, and I'm going to subtract 2x on both sides. And we get 6y equals negative 2x plus 12. And then I can divide everything by 6 to get my equation in slope-intercept form. Negative 2 over 6 is going to get me a negative 1/3 x. And then 12 divided by 6 is 2. Again, I don't care about that 2. I only care about the slope. So if my slope is negative 1/3, right, a slope that's perpendicular to this line is going to be a slope of the opposite reciprocal. Now, opposite of a negative is a positive, and the reciprocal of 1/3 is 3. All right, so 3 over 1, which is just 3. So I'm going to use 3. Right, I don't need the over 1. Right, so I'm going to use 3 as my slope and plug it into point slope form using this point right here. So x1, y1. So it's going to be a y minus y1, so y minus 3 equals m, so 3 times x minus x1, so x minus negative 1, so plus 1. and then convert this into slope-intercept form. So I get y minus 3 equals 3x plus 3. All right, add 3 to both sides, and I get y equals 3x plus 6. And then that's the equation of our line. All right, and then lastly, I want a line that's perpendicular to y equals 5x minus 5 that passes through this point right here. All right, this one's already in slope-intercept form, so I know that m is going to be 5. And so that means a perpendicular line is going to be the opposite reciprocal. The opposite of a positive is a negative, and the reciprocal of 5, well, think of it as 5 over 1. And then I can just flip that fraction, and this is going to be negative 1 over 5. So this is my so this is my opposite reciprocal. So this is my perpendicular slope. So I'm going to use negative 1/5 and 3 comma 0 as my x1, y1, and then plug this into point slope form. So it's going to be y minus 0 equals m, so negative 1/5 times x minus x1, so x minus 3. And then I can distribute negative 1/5, and then y minus 0 is just going to get you y, right? Anything minus 0 is itself. So negative 1/5 times x is going to be a negative 1/5 x, and then negative 1 over 5 times negative 3. If you need to do that to the side, you can, right? So if I do negative 1/5 times negative 3, that's the same as 3 over 1. And then when you multiply straight across, I get a positive 3 over 5. So plus 3 over 5. And then this is the equation of my line in slope-intercept form. All right. That's all the major topics of this lesson. I know it's kind of a lot, but hopefully it's stuff that's familiar to us from Algebra 1 and geometry.